Welcome to another 88K model railroad video, and in this video we're going to start to bring some of the pieces together. Now, we were on a bit of a detour when we went through the validation process with the ESP32s and the 8266, but it's something that was worthwhile. We gained a lot of knowledge. Now what we're going to do is apply some of that knowledge. Now, before I went on the detour, I was working on setting up a mock-up of the wiki demo layout, and the next step after I went through the PyPico was to create the sensors, and now I'm back to that point now. But what I plan on doing is creating a module, a sensor module that I could move around on the layout and that I could install them readily. So what I was going to do is embed the sensor into the track, and I use the Kato. I do N scale and then HO scale, and I use the Kato Unitrack. So I'm going to use those track pieces as the basis for the sensor modules. Now I need to be able to identify the levels or the voltage levels that the sensors give out. And what I end up doing is using the 8266 and some of the sketches to create a light meter. And in this video I'm going to show you how I created the light meter and kind of put things together, and then how I'm going to use it. So we're going to go through the parts, the build process, the firmware, the sketch, and then I'm going to test it out. So let's get over to the bench. So here we are. These are all the pieces. We've got the ESP32. Here's the perf board. Then we've got the sensor, but then I've got to get the sensor with no the header pins removed. I think this one I have, but I'll get another one without the pins because we want a wire and we want this to be flat so we can place it anywhere on the track. Then there's the 3 pins. These are the JST type connectors. Here's the what they call the through hole connector, and then this is the actual socket, I think, or this is a socket and this is the connector. So we're going to use that. We're going to build the board, and then after that I'll probably make a casing for it, and then that way it's all complete. I'll use this shorter wire initially, and my thought is that it doesn't need to be that long, and then we can just lay it on the track for area sensor, and then but also be able to put it under the piece of track to test how much light is getting through the lens that we're going to make. So let's go ahead and start with this assembly. Here we have the pieces. I took the sensor, soldered it onto the, this is called a TEMT 6000. Then this is the JST 3-pin connector. I crimped this. There's a special tool that you can get, a crimp tool that will crimp these small connectors. Then I soldered in this this through hole mount, or I think this is called a socket, connector and socket. Then on the back I wired it, and using that the wire wrap tool, I wire wrapped the signal lead here to the analog input. Then this is the 3 volts here, that's the red lead that goes in the center, and then this is the ground here right in front of the 5 volts. So the connector will go in like this, and then here's the black lead, the ground, and the center lead is the volt or the VCC, or the 3 volts, 3.3 volts, and then this is the signal lead coming back. So now this is pretty much the board. We've got it ready. Then what I think I'm going to do is just make a case for it, and then that way these pins can be protected and they won't get shorted out. So I'll do the case, and then probably leave this open just to ensure that there's a good signal, that you don't break, get a loss of signal, which it doesn't matter, because I think this one I'll be using for the USB connection that goes into the back of this, so I don't think I'll be doing Wi-Fi. Maybe I'll see if you can do this remotely, and that way you could put in a battery module here to power the board up, and then you could set this anywhere and then go to a terminal and then read the voltage. So that'd be a neat thing to do, but I'll not right now. I'll just, next thing I got to do is just make the base for this. So let me do that. Okay, so here's the piece, the module. This kind of gives a good idea of the shape that you want the case in. And I made this real quick out of acrylic, so I cut the shape. It gives you a general idea. And then maybe later I'll make a actual case or a full enclosure. And this could go back just a little bit more, maybe a half an inch more go back. And then I think you could probably put more of these connectors in to have different types of connectors, so you could set this up for 3 or 4 different usage. So it all depends on what IO pins that you use. So that might be good for the next iteration, but for now this is good. It's usable for the short and long term. So this goes in here. So there's the sensor. Then you can place it on the track, and then that's what I want to do, is to place it below the track here, and then get light readings based upon how big this aperture is. And then I can kind of test out the lens that I want to put in the track. So this test piece is pretty much done, and I think the next thing I got to do is just write it into the flash it into the chip, and then after that do a test. So we'll do that.